Cool. So welcome again to Simplifying Data Streaming with Apache Kafka on StreamNative platform. We are two presenters here. We have Dustin Nest, who's a trainer, and myself. So I am a product manager for StreamNative. I just recently joined the company 4 months ago. I've spent over a dozen years doing product management, mostly around dev tools and platforms. And I've also been an Apache committer in the past. And so, by the way, I didn't give my name. My name is Karan Malhi, and I'll pass it over to Dustin. Dustin, why don't you introduce yourself?
Sure, I'm StreamNative's technical trainer. I've been here for over a year. So I guess we could probably say over 8 years in training and support now, because I did work in software for quite a few years before coming to StreamNative. My background is actually in chemical engineering, and you can get in contact with me at any time by emailing training-help@streamnative.io. That's important because a lot of the content in the demo is going to be related to training and how you can get started using StreamNative with Kafka.
Very cool. Thank you, Dustin. By the way, my background, I've been a trainer myself, and I can tell you that it's a lot of hard work, and Dustin just takes it 10x levels higher. So if you do get a chance, do take his training courses. All right, so let's get started. The agenda here is we start with talking about familiarity, change, and business growth. Really short, just to anchor the discussion. Very brief journey from monoliths to cloud native and where Kafka fits in. Then we transition to the one StreamNative platform, which is our data streaming platform. And then we talk about Kafka on StreamNative and how you can benefit with running Kafka workloads on the StreamNative platform. And then finally, there's a demo. So usually it's going to be like a split. I'll speak for 15-20 minutes. Dustin is going to go through the demo, give you the demo, and then we open it for Q&A. Okay, let's get started. So let's talk about familiarity, change, and business growth. And these are some anchor points just which I want to use throughout the presentation. And I want to start with, because this is about Kafka on StreamNative, one thing we all agree upon is Kafka is familiar. Everybody knows about Kafka. Whoever works on the data streaming platform knows about Kafka. Okay. And when you talk about familiarity, generally you take decisions with things which you're familiar with. And when you have a big cognitive load, when you're thinking too much, there's too many things at hand for you, you generally go with familiar things. Okay? So you generally will pick Kafka if you wanted to pick a data streaming platform or a solution, or the OS is Kafka. Okay. So in software, such decisions can sometimes lead to wrong and costly architectural choices. And I'm going to talk about how and when, in what specific cases. Another thing I want to talk about is we always say change is constant. There's changes and we adapt to changes. We've all adapted to Amazon shifting our behavior from going to the brick and mortar store to going online shopping, or going to pick up DVDs and Netflix changing it to online streaming. However, there is one more thing which is constant. It is cost. So in software, cost is a big thing, especially now after COVID and after all the remote work started and the economy and what the world is going through, the geopolitical situations and everything. Cost has become one of the primary concerns. And the result is going to be that profitable businesses, as always in the past, in the history, will live and others are going to die. So if we don't look at the equation, the simple equation of revenue minus cost equals profit, and if we don't see a positive profit, the business is going to struggle. Now, when you're talking about cost in the software world, especially in the cloud world today, you're talking about optimizing resource utilization. That's one of the primary ways to save costs. And resources means the very skilled people, the developers, engineers, who put in all the hard work to build the software we use today, and the folks on the SRE ops side who are actually managing and maintaining the infrastructure. Okay. So keep these things in mind. Keep things in mind that familiarity-based decisions can sometimes lead you the wrong way. And it's a changing world. so change is constant, cost is also something which is constant. We have to keep in mind with the changing world. Okay, so talking about change, let's talk about what changed in the past couple of decades. Quickly, briefly, we started off with, in the software industry, we started off with monoliths. So late 90s, early 2000s. If you look at the left, what you see in the picture is on the left is developers, on the right is the ops. Okay, so we had a low dev to ops ratio, which means developers would build and ops would operate, and there were more operators, for X number of developers. So the ratio was low, but the cognitive load was still there, and people brought in agile principles, etc., to try and manage that cognitive load. Okay. Then came DevOps, the shift left movement. So now you had developers who had more responsibilities. They started coming on call. They had to also know the infrastructure details. Okay. Ops from the right, some part of the ops got shifted and embedded to the left with the developers. Okay. And ops started thinking about, how do I make a self-serve infrastructure so developers who are building and owning it can use it? Okay. Cognitive load started to increase. Okay. We still didn't see a change in the mix of people. Okay. It's just that some people shifted from one team to the other team. Then came containers and Kubernetes. And this is where you saw, the main idea was that you have SREs and ops, and a small team can manage more number of developers. You still had embedded SREs and ops in the developers side of things. So now developers the cognitive load kind of increased exponentially. And the developers had to not only worry about on-call and infrastructure, but also build and learn about architecting their services. Okay, so things changed over a period of time. And on the SRE side, people started building platforms, okay, because the complexity was just too high. They had to abstract things away. So when Kubernetes came in, people also started thinking seriously about modern cloud-native platforms. But a lot of focus was on technology, not on revenue and costs and how it impacts revenue and costs. So if I put down like these 5 pillars, let's say, okay, these are not a comprehensive list. In a modern cloud-native platform, you have microservices on Kubernetes, which increases parallelism in teams and leads to higher revenue. Okay, auto scale up and down, multi-tenancy. These are requirements. These are absolute requirements for modern cloud-native platforms. Okay, data streaming or not, and these lead to lower costs because they lead to optimal resource utilization. Security and observability are other ones which lead to higher revenue. So they fit in that equation, that higher revenue minus lower costs is increased profitability. And remember that we said businesses who live historically for hundreds of years are the ones who are profitable. Okay. So in this modern cloud native platform, and with all of these things changing, we have a familiar Kafka. Did we adapt our data streaming platforms to that change? Unfortunately, we still went with the solution which was familiar to us, but which did not fit in that modern cloud native world. It did not fit with Kubernetes, auto-scaling, multi-tenancy, geo-replication. It had limitations, and as developers, we find challenging situations interesting, and we try to, make do with whatever we get, and we make it work. Okay, but do you have the bandwidth to make it work? Do you have the time and the money to just make it work nowadays? Okay, so what it did was what went down. If you saw the couple of slides back, what went down where the operators were reduced because of Kubernetes. Now suddenly, because of Kafka, you need more operators again. You probably need a dedicated team to run your data platform. Okay, there's more downtime, failures, etc., and it causes a lot of stress. So I kind of coined this term. I don't know if this term is out in the industry or not, but I coined a term called software-induced stress, or SIS, and Kafka causes that. Okay, you're always worried about your data platform. Now, why is that the case? Why did that happen? Why does Kafka not fit into the cloud-native world? Well, if you have to look at the timeline, Kafka was built in 2011, and Kubernetes came out in 2015. Okay, and it was architected and built for the pre-container, pre-Kubernetes world. Now anything you do after that, after the fact, after the basic core architectural tenets were set, okay, it's actually working around the problem. So it's like you built some software for one operating system, and now you want to port it to another operating system, and you have to do all these patches to make it work on the new operating system. And Kubernetes is the operating system of the world. Okay, so it just doesn't work. Pulsar, because StreamNative is a company which behind Pulsar. Pulsar, on the other hand, was released after containers and Kubernetes came. It was built at Yahoo, which had all these use cases of messaging and data streaming. Okay? And Yahoo was and is an internet scale company, but they had been the longest possible survivor in the internet world, pioneered internet world and content. Okay, so they'd seen through the years, and they'd seen through multiple orchestration engines and frameworks, and they settled on Kubernetes. So they also looked for their data streaming platform at other solutions out there. They looked at Kafka, but it didn't fit their needs, just like all other enterprises today. So they built it themselves, built Apache Pulsar, which became a top-level project. And it resonated so much with the folks out there that immediately there was a lot of pressure. There's a lot of interest from the industry to see a company back it and provide a commercial solution around it. And that's where 2019 StreamNative was born. Okay. So given that Kafka is familiar, but the world is changing and it's not fitting into the changing world, okay, which increases costs and thus reduces profitability. What are the shortcomings? Why does it not fit? So I'm just going to give you a couple of examples here. I'm not going to go through the whole list. There are other webinars which you can look at. They're recorded, which talk in more detail about the technology side. So the first one is no multi-tenancy in Kafka. Okay, just to give you some background, I was a platform product manager for a large company, very large company with 9 AWS regions, and I put together Kafka as a service for our developers on our platform. And multi-tenancy was a big issue. How do we share resources? You couldn't. The existing status quo was people had taken open source Kafka and each team had made their own cluster, and there was a cluster sprawl. Okay, and because of that, there was a lot of complexity in operating it because the teams built that and then they handed them over to us. Okay, and there was a lot of custom configurations and stuff like that. We couldn't put consistent security policies. Okay, resource utilization was at the bottommost. It was really costly. Okay, so we got pressured. I was put under a lot of pressure in the sense, or got some requirements from the CTO saying, I want a cost-effective data streaming platform which is highly available. Okay, and that's where I worked on providing data streaming as a service. So multi-tenancy doesn't work in Kafka. You can work around it, but it just doesn't work. Okay. Similarly, scale. If you're trying to scale, if you're trying to add more consumers, okay, you'll have to add more partitions, and then you have to wait for things to rebalance and all that stuff. So there's a lot of overhead, okay, which means that you have to literally predict the future. And predicting the future means you'll have to literally go and say, I, as an engineer, sitting within my cloud native platform team or my data streaming platform team, now have the responsibility of predicting what my business volumes are going to be in a year and at various points in the year so that I can plan for it. And the way you plan for it is you just over provision. You over provision for the get-go. That's what I did. Okay? 27 clusters, over provisioned to start with, not a single customer on it for a year. Okay? But that was the reality. That was the only way you could get past this. Okay. Then people start using familiarity and say, oh, I already have Kafka in my infrastructure. And this is somebody actually telling me, this is one of the big companies, and I recently interviewed that SRE, and that person was frustrated saying, I have this really big problem where we have Kafka in the infrastructure, but because we have it, people also start using it as a message queue, and it's not built for that. Okay, and then we hit in all sorts of problems, all sorts of questions, and that just increases the load on us, the SRE side of things, because developers have so many questions. Of course, you can't blame developers because they don't know the message queue, how to use Kafka as a message queue, but somebody chose it for them. So again, Familiarity, here's another case. Familiarity leads to a solution which you pick, which is costly and is not adapted to the changing world. So how do you solve this? How do you solve all this Kafka not fitting in? So what fits in? And this is where the one StreamNative platform comes in. The one StreamNative platform is based on Apache Pulsar technology. It's built-in multi-tenancy. You can set quotas. See, one of the big problems with the technology stacks is that you can, and this is something I experienced personally, I can bring in a vendor, I can bring in a technology stack, but it's really hard to take that and adapt it to my workflow and adapt it to my team structure. Okay? If I have to have resource utilization and cost as my primary concern, I need to make sure that the resource is utilized properly. And the only way I can do that, at least in the data streaming platform side, is by assigning quotas to people. Okay? Assigning parts of the resources to people, isolating them, and so on. And it's really hard to do with Kafka. So that was something, because Pulsar was built at Yahoo and they had different hundreds of teams. That's something they thought out of the box. It should be there. So multi-tenancy is part of it. You can set quotas. You can assign resources to teams. You can isolate them. Geo-replication is part of it. Yahoo was a big business, a global business. So they wanted to make sure that data can be geo-replicated to other regions. Tiered storage is part of it. Storage is costly. SSDs are costly. Okay? You don't need all the data all the time. So tiered storage was out of the box. Okay? So when your architecture supports these core tenets, it becomes easy to start building other use cases on top of it. Okay? I'm actually reminded of a recent book I read by Frank Slootman, who is the CEO of Snowflake right now. He was the CEO of ServiceNow and another company called Data in Motion. All three highly successful companies. He basically said one thing. He said, the core reason why we were successful is because our architecture supported all the additional use cases we could add. Okay. So this is where the one StreamNative platform comes in. It not only supports data streaming, it also supports messaging. Okay, MQTT, MQP, and so a lot of people come to us for, hey, we're using RabbitMQ, it's not scaling, can we use you? And it's available as a private cloud, or you can bring in your own cloud, or we have a hosted offering. Okay, so the core things in this platform is the level of elasticity. Okay, you can scale the number of messages consumed. Okay, you can scale the number of producers and consumers. You can scale storage separately, and the fundamental reason behind it is because of the architecture. You have brokers which are stateless, unlike Kafka, where brokers are stateful. Kubernetes works with stateless stuff. Okay, you have bookies which store the data, but they have to be stateful when you can't get around them. But that's a dedicated, separate, state-managed architecture. And then you have producers and consumers. Okay, so this is the key. This is the key to a long-term, dedicated data streaming architecture. And what it allows you to do is, you want to scale brokers, just add a stateless broker, and it's done. There's no data movement, no migration, no rebalancing, nothing of that sort. If you want to add storage, you can add new bookies and messages start coming in right away. Okay? Again, no rebalancing, nothing of that sort. And then if you want to offload, if SSDs are expensive, you can offload to your tier storage of choice. Okay. So in short, these three levels of elasticity will really help you in the Kubernetes world, because it's all about elasticity. Remember that Kubernetes has this notion of operators, which means I don't want to do it manually. Somebody should operate that for me. Okay. Then there is built-in geo-replication. Okay. This is built in, and you can do it at the namespace level. Dustin, you reminded me yesterday. So, and this is one of my favorites, multi-tenancy, because I've personally gone through trying to assign resources to teams and quotas and putting RBAC on top and removing noisy neighbor, and it's really, really hard to do in Kafka. Okay, so multi-tenancy is again part of the platform. So you have all these goodies. You have all these goodies which fit perfectly in the Kubernetes and the container world for your data streaming platform. What are you going to do about your Kafka investments? Okay, usually people fear that, okay, great, Karan, you talked about all of this stuff, but I already have my investments. And that's where I want to talk about Kafka on StreamNative. Okay. I talked about familiarity. you should be able to leverage your familiarity. Familiarity itself is not a bad thing. If you're familiar with something, you can do things quickly, so it's great, okay? And if you've already done things, then you should be able to use them. But you should also be able to move on to the changing world and adapt to that, okay? So Kafka on StreamNative, the concept is very simple. You have Kafka clients, which you already wrote. They're using the Kafka protocol. Just replace the Kafka cluster with the Pulsar cluster with the one StreamNative platform, and it works. Okay, Kafka protocol is kind of becoming an industry standard, so it actually works. The benefits here are you immediately boost your data streaming platform. There is no effect on, there's no need to retrain your developers. There's no need to rewrite your clients. Okay. You can consolidate many tens of Kafka clusters into one StreamNative cluster because of the way it's architected. And the resource utilization is amazing. You'll see immediate, really big cost benefits just by doing this, okay? So leverage familiarity to bring in a positive change. Here's a list of supported features. Most of the Kafka features are supported. KStream, KSQL, topic compaction, transactions, etc. Okay, you can actually go to our website, to our documentation, and you'll be able to see Kafka on StreamNative, more details there. But I'll stop here, and I'll just say one thing. Adapt to change and make the change. You be the change. So bring that in. Check out Kafka on StreamNative, and I will pass it on to Dustin to give a demo of all the stuff I talked about. I'm going to stop sharing.
Thank you. I'm going to go ahead and share my screen. Hopefully you should be able to see it now. So there's two parts really to the demo. I want to show you some of the features working of Kafka on StreamNative. So using some native Kafka protocols against the StreamNative 1 platform. But the just as important as that is, how are you actually going to get started as a developer in testing this out and seeing how it works for you? So I want to show you how easy it is to use your existing Kafka code and exactly what you need to go through. In addition to that, we have a course. So I'll talk about that in just a second as well. That'll help you get started. So the easiest way to get started is to hop on over to the streamnative.io website. You'll end up with this page here. As you can notice, there's a free credit, a $200 credit. That's going to let you spin up and test a StreamNative hosted cluster. And that's one thing you might want if you want to test some of your own code. In addition, while I'm going through the demo, a lot of the code, actually all the code examples I'm going to be showing are included in the course. So if you go over to Learn and then go to StreamNative Academy and you scroll down, there's this KSN Kafka on StreamNative Developers Training. This is a completely on-demand training. You can start now and get access to the course. You're going to get access to all the code I'm about to show and directions on how to set up security, things like that. When you take the course, there's really two options of how you want to publish and consume your messages, because you're going to need access to a cluster. The first option is to use the $200 credit and spin up your own cluster. The other option is to contact me, and I'll give you a tenant inside our training cluster, and I'll actually set up the security for you. So it makes it even easier. And it's actually the exact same cluster I'm about to demo on. Let me go ahead and log in. Since we're going to be going into the code, and I need to show you what changes need to be made to that code for the demo to work against the Pulsar cluster here. There's really two things that you need to adjust in your code. The first is the endpoint. You previously were pointing your code to a Kafka cluster. If I go to Pulsar clusters here, let me select my cluster, and I go to details, there's going to be access points. The Kafka service URL is going to be the URL that you need to point to the Pulsar cluster, but it's the Kafka endpoint for Kafka on StreamNative, whereas this is where you would connect if you were using the Pulsar APIs. And then during the demo, we're also going to be showing how to use the schema registry for Kafka. And that's this endpoint here. So that's the first thing. You need your endpoints. Super easy to get them out of the UI. The second thing is you're going to need some sort of access. That's under service accounts. And I've created a non-admin service account here. There's two ways to connect to the platform. I'm going to be using both in the demos. The first is to use either a JWT token or an API key. Those actually are the same mechanism. It's the plain mechanism. And then there's also the OAuth 2 key if you wanted to use that as well. I'm going to be showing both in the demo. So now that I've really shown you where the class is, how to spin up a cluster if you want one, or you can email me to get access, and then the two main things you need, which are the endpoint and the permissions, let's hop on over to some code, and this is the exact same code that you would get access to if you were to take the course. First, I just want to show you the simplest example with no schema and using a JWT token. And just to demo something, I'm going to be using a example that uses transactions. So this particular file, this is all Kafka code here. I'm not going to make any changes in my Kafka code. This actually uses a client.properties file. So the only changes I'm going to make are in that file instead. I also have an example later, and there's more examples in the course where if you want to set, if your security is set up and your endpoint is set up directly in your Java code, that's actually right here in this transactions v2. That's not using the client.properties file. So if I go to client.properties transactions, normally you'd have a bootstrap servers and the config for your plain mechanism. And when I tested this against a Kafka cluster, and it worked totally fine. All I needed to do was change two things. That bootstrap server, this was the URL I got out of the UI. And then here is the plain mechanism configuration. I just changed the username, and then the password is token, : and then that JWT token I pulled out of the UI. And again, this is all in the course. This file is used for both the producer and the consumer here. So let me start up the consumer first. And it starts up the while loop. And then let me start up the transaction, or the producer with the transaction. So here it produced, the code I have waits 5 seconds before it actually commits the transaction. And then as soon as it commits, you can see that the consumer gets it. So this is your first easiest example of using a producer and consumer with a client.properties file and a JWT token. All I needed to do was change two items in my client.properties file. One was the URL, and one was the actual connection information with the JWT token. If you want to use OAuth 2, it does become a little, you need to make a few more changes. Let me go into schema. I'm also going to be showing an example with schema when I use OAuth 2. Let me go ahead and close out this consumer and this producer. Here I have Avro producer. It's a generic record. I'm just defining the schema here. Again, none of the configuration of the connection information or the security is done inside of this actual code. Instead, I'm using the client.properties file. And again, the schema v2 here has this exact same example where I just do it all directly in the Java code. So there's an example there for you. So here in the schema client.properties file, again, the bootstrap server, super easy to change out. That's just this change here. For OAuth 2, there is going to be a few more changes that you need to make, but you basically just have to copy and paste this code in. You're changing the mechanism from plain to OAuth bearer. And then, of course, you have to have your issuer and your audience defined. And we have our callback handler. I mentioned to use OAuth, you're going to get that JSON file out of the UI. I just dropped that here in the resources folder. I believe it's this one for this cluster that I'm pointed to right now. And then here, I just have to do a path, a relative path to that file. That's going to get my OAuth up and running for my producer and consumer. For the schema, I haven't defined that yet. That's down here at the bottom. Normally, you would have your schema registry URL and your basic auth user info. I just switched the schema registry URL to the schema registry that I got out of the UI. It's actually almost the same endpoint as for the producing and consuming with Kafka, the Kafka on StreamNative endpoint. I just have Kafka here, and it's not on the port 9093 up here. And it's an HTTPS. And then you have the option of using either the JWT token or OAuth for the schema as well. If you use the JWT token, you just drop it in right here, like I have. And if you want to use OAuth, I have that configuration in the course as well. And it piggybacks on some of the configuration up here. So you don't have to redefine the audience and the issuer and things like that. it's going to use that same callback handler to authenticate in. So if I go ahead and run, let me run the consumer first. And then let me run the producer. Put them side by side, actually. So you can see here that it was able to produce the messages with that schema, and then it was able to consume them. And then in the consumer, there's no record of what the schema is. It's actually pulling that out of the schema registry. There's nothing in here, whereas the producer is the one who defines that schema and then registers with the schema registry for the consumer to see that. You just run the producer one more time, and you can see it produce on the left, and it'll show up on the right in the consumer. So this was the second example where we're using OAuth now with the producer and consumer. I continue to use JWT for the schema. So you can see the schema registry working as well. There's one final example I wanted to go through, and that is using KStreams. And in this particular example, let me close out my consumer and my producer. In this particular example, I introduced multi-tenancy. And again, this is all included in the course as well. I'm going to be consuming messages for this particular case stream. This is a word count application. I'm going to be consuming messages out of this particular tenant. And then there's this namespace. And then the topic itself is called shared topic. Case streams can take a little bit of time to start up because of the way the API works. So let me start that first, and then I'll explain what I mean by shared topic here. If you're using a particular, either a string type message or a byte type message, in either of those two cases, you can actually share the topic. And eventually we're going to be expanding this to more types of messages as well. But if you're using either a string or a byte type message, you can actually share those topics between both Kafka and Pulsar. So here I've started up my application, and I'm going to produce a string message to it. Let me go into shared topic here. I'm going to actually produce a Kafka message into that. So I produced this message called published by Kafka producer. And the stream application has now received that message. And again, this is using multi-tenancy and KStreams on Kafka and StreamNative. And it's doing running sum of the number of times each word has been seen. So it's adding up the word published by Kafka and producer. So total times when the application has ever been run. So it's using a materialized method here to store that data. And that's stored in topics as well. The total number of times published by and producer has been seen as 17 times. And Kafka has been seen 11 times over all of the messages that it's ever processed. So let me run this again. And what we should see is that it says 18, 18, 12, 18. Because it's going to go up one more time each. And that's exactly what we see, 18, 18, 12, 18. But since I'm using a string type, I can actually share topics with a Pulsar producer as well. So let me go ahead and use my Pulsar producer application here. Again, you can see it's the same tenant namespace and topic. And I'm going to, this time instead, produce a message that says, published by Pulsar producer. You can see that the KStream application has now seen that. And now the words published, Kafka, and producer have increased from 18 to 19, but the word Pulsar has only been seen 7 times. I ran it 6 times before, and now this is the 7th time it's seen it. So if I go ahead and run that one more time, it should say 20, 28, 20, because it'll go up by 1 for each. So KStream application has now seen that, and it'll process it, and it'll go up in just a second. While that's processing and adding that up, that's just part of the Kafka API. You may have also noticed, and there it just finished, my namespace here is geo-rep. And Curran mentioned that geo-rep is something that's built into Pulsar. Now, we can actually geo-rep these string and byte messages to another KSN, Kafka and StreamNative enabled cluster and consume them over there as well. Again, currently it works for all types of messages for Pulsar, obviously. But for Kafka, it works for string and byte messages very well. And we would be able to geo-rep them. He mentioned that's done at the namespace level. Actually, the interesting thing about geo-rep, and this is actually also included in the course, an opportunity for you to test out geo-rep. To enable it, you have to connect or provide your cluster connection information to the other cluster. Now, because you've done this multi-tenancy where everyone is on one cluster in Pulsar, you don't necessarily want everyone to be able to, I shouldn't say access, but have the ability to use those credentials to access that other cluster. So you actually turn on the ability to reference those credentials at the tenant level. So only specific tenants have the ability to see the credentials that point to other clusters. And then, as Karen said, you actually turn on geo-rep at the namespace level. So the tenant admin then is able to turn it on at the namespace level, which means that any topics inside of that namespace would automatically be geo-repped to the other cluster, just as though it was any other consumer consuming messages and then producing them over there. And that's the great thing about Pulsar geo-rep, is it actually piggybacks on the exact same consume and produce mechanism that we already have. And that just automatically is part of Pulsar. It just works. So I've gone through 3 examples. One was to do JWT with the producer and consumer. Then we did the schema registry where I used OAuth for the producer and consumer, but JWT for the schema, but OAuth is also an option. And then we did an example KStream's application here, where we also used a shared topic, which was of a string type message that we could produce messages with either Kafka or Pulsar. And the great thing about that is not only would KStreams consume this, but you could have a Kafka producer and then a Pulsar consumer, or the other way around. They can consume and produce from everyone because it's actually the same topic. It's not like we have Pulsar topics and Kafka topics. They're all Pulsar topics. You're just using the Kafka protocol to produce and consume. So just a couple more things. If you take the course and you want to learn more, I have links and there's additional information about things like topic partitioning and how that scales really well. Message retention in Pulsar is going to be very important to you. And topic compaction is another common topic that comes up a lot, and it may be slightly different. There's information in the course about that, about how topic compaction works. And then one more time, I want to head back to the UI just to show you guys. Let me see if I can find it. Here it is, back to the UI. If I go back to my streamnative.io to get started, you can use that $200 credit on streamnative.io to spin up your own hosted cluster. To get started on the training, if you go to StreamNative Academy, scroll down, there's the developer training, and then there's 2 ways to test the code. Again, all the code examples are in that training. One is you can use the $200 credit to host up your own cluster, or to spin up your own cluster, or email training-help@streamnative.io. It's also in the course, that email, and I will give you access to a tenant inside of the training cluster. With that, I'm actually going to pass it back to Kurt to finish up with any Q&A.
All right. I have one last thing to show, that we are having a virtual Pulsar Summit, EMEA, on May 14th. So if you're interested, please come in and register. I've learned a lot. I mean, before I joined StreamNative, I actually went to the Pulsar Summit in San Francisco, and I ended up talking to a few customers just to gauge, where they find value, and that's when I decided to join StreamNative. So it's a very valuable summit. It's virtual, so you can join remotely. Also, Dustin already mentioned, we have a $200 credit to try out the training and try out Kafka on StreamNative. And if you want to reach out to me directly, my email is right there, karan.malhi@streamnative.io. Happy to answer any questions there, and happy to also answer any questions right now.
And actually, let me just say one more thing. We don't want you to just try out the training. We want you to try out your code. So we actually encourage you to use the $200 credit to spin up a cluster and then test out your code. But the course will give you information about how to connect your code to that cluster.
Yeah, good point. Okay. I don't know, how did I get this question? Somebody looks like DM'd me. So Dustin, are there any libraries? So one question is, are there any specific Pulsar libraries you need to add to your clients to make your code work?
So I would check the documentation for what versions are supported. For JWT token, it's the plain mechanism, so you should be able to just use the same client versions as you already have. That should work totally fine, as long as it's one of the supported versions. OAuth 2 does require certain versions. That's also in the documentation and in the course, because OAuth 2 uses our callback handler, which was using an external callback handler like that, I believe was not inherently supported by the older versions of the Kafka libraries. So to use OAuth, you would have to upgrade to specific versions of the libraries.
Okay, cool. All right. We also have another question by John Harvey. The question is there anything similar to KSQL DB for Pulsar?
I don't believe, actually, I think there is. We can get back to you. We actually do support KSQL as well. We are not going to spin up the KSQL server for you. That's one of the reasons I don't often demo it, is because it still uses a KSQL database, but the KSQL database can still connect to Kafka on StreamNative, and I have gotten that to work and demoed it. And I believe, Curran, if you go back to your supported features, that's 2 slides up. That's actually one of the supported features. KSQL, I believe we do actually. I've never used it myself in training, but we can definitely get back to them with more information on. Yeah, because I think David has some videos on the different options for using SQL against a Pulsar cluster. There should be on the StreamNative Academy YouTube channel some other videos on that David has done.
Okay. All right, thank you. Anybody else has any questions? Okay, nobody else seems to have any more questions. So thank you so much, everybody, for joining. And thank you, Dustin, for showing the demo. See you all hopefully see you all at the Pulsar Summit, and excited to see how many of you spin up a cluster and try StreamNative. And if you have questions, again, here are the emails. Reach out to Dustin through traininghelp@streamnative.io and reach out to me at karan.malhi@streamnative.io. Thank you and have a nice rest of the day. Bye.